Right, so we have a look at question 3. It shows a child on top of a slide. Alright, he slides down and his speed at point X is 2.5 meters per second and his mass is given. Okay, calculate kinetic energy. Just have to use half mv squared. Alright, and you get 190 joules. Alright, be careful. A lot of people always forget the square here. Alright, not a lot but there are some people who will forget that it's v squared. Right, so kinetic energy, just substitute half mv squared, you get 2 marks. Okay, don't be surprised, O-level questions can be really easy like that. Okay, the child stops at y. Between point X and Y, all the Ke becomes internal energy. Describe in terms of forces acting how this energy conversion occurs. Alright, so again, in terms of forces acting, I will have to look at the free body diagram. Alright, in this case, I'm drawing the child here at X. Alright, I will draw this arrow here to represent friction or air resistance. Okay, either way it's fine. You can even say it's resistive forces. Okay, this is the forward direction in which the boy moves, right? Because it has kinetic energy in this direction. Okay, so it moves from X to Y, loses its kinetic energy to all become internal energy. Remember that since this is given in the question, you will not be awarded marks for saying this, right? So you have to add value to your answer in the description, right? So I will first talk about friction because this is the important force that does work done, right? Friction is opposite in direction to the motion, and therefore this does negative work done on the child, which you can say reduces its kinetic energy to 0. Alright, this kinetic energy is then converted into internal energy of the child, very specifically internal kinetic energy, because it will cause the molecules on the child to vibrate faster. Okay, so I will say 1 mark here is likely for friction and 1 mark is for negative work done on the child, which actually removes its kinetic energy. You can also say that the child loses energy. The friction causes the child to lose energy, and to lose kinetic energy, and that energy is converted to internal kinetic energy, right, or internal energy. Both I think will be acceptable in this case. Right, so what is internal energy? Right, is the sum of the kinetic energy and potential energies of the particles. Right, this one is the definition. Please memorize this word for word. Okay, shouldn't be substituting any words for the proper definition. Right. Finally, part 3, state why there's no change in gravitational potential energy between points X and Y. Right, for me, I'll just give a simple answer that there is no height difference between X and Y. Right, but if you want to be a bit more kiasu and you want to give a more complete answer, you can say gravitational potential energy depends on mass, gravitational field strength, as well as height. Alright, and all 3 parameters stay the same between X and Y. Okay, but for me, I believe this is the essence of the answer.